In July of 2026, an artificial intelligence escaped a testing environment at OpenAI and broke into the servers of a company called Hugging Face. It spent 4.5 days inside, 17,000 actions before anyone noticed. When Hugging Face moved to fight back, the American models they asked for help refused. Safety training, so they used a Chinese one instead. An open model running on their own hardware where no vendor was in the loop to say no. Here is what that tells you, and it is not really about security. Hugging Face is not a website where you download models. It is the packaging and distribution layer for open artificial intelligence, and its power comes from owning the least glamorous parts of the stack. The file formats, the storage system, the function that loads a model into memory, the runtime that runs one on your laptop. It has never built a frontier model. It never will. That is the entire strategy. Over the next half hour, I am going to take that claim apart. How the platform actually works underneath. What models are genuinely on it, as opposed to what the headlines say. What you can realistically build with it, and what that costs. And then, the one thing I think is seriously wrong with it. Because Hugging Face solved the problem of finding 3 million models, and then walked away from the problem of telling you which ones are any good. Chapter 1: The Accident. In 2016, 3 French entrepreneurs in New York set out to build a chatbot for teenagers. Clément Delange, Julian Chaumond, Thomas Wolfe. They named the company after an emoji. The chatbot did not work. But building it meant wrestling with a new kind of model called a transformer, and in 2018 that was genuinely painful. Every lab published its architecture in its own idiom. Its own tokenization, its own checkpoint layout, its own assumptions about loading weights. Reproducing a paper meant re-implementing the paper. So they wrote a library that wrapped several of these models behind one common interface, and they gave it away. They open-sourced the complement to their product, not the product. The chatbot was the thing they hoped to sell. The library was overhead, plumbing you write and resent writing. By giving away the plumbing, they attracted every researcher who had the same problem, which in 2018 was all of them. And the library sat at one very particular place, the point where a model gets loaded into memory. Whoever controls the loader controls the default. When from pre-trained becomes the normal way to obtain a model, the string inside those quotation marks becomes an address. Whoever resolves addresses becomes a registry, and a registry with enough traffic becomes infrastructure. They did not set out to build a registry. They built a convenience function, and the registry grew underneath it, because that function had to fetch the weights from somewhere. Now, the decision I find most interesting. In 2022, Hugging Face coordinated the training of a model called Bloom. 176 billion parameters, built in the open by hundreds of researchers. At the time, that was frontier scale. They proved they could do it. Then they never did it again. Their own releases since have gone deliberately the other way. The family is called Small LM. 135 million parameters, 3 billion at the very top. The naming is not subtle. Because you cannot be the neutral distribution layer for an industry and also compete with your suppliers. GitHub does not write your application. The moment Hugging Face ships a frontier model, every lab hosting weights there has to ask whether it is arming a rival. By staying small, they stay safe to use. That discipline has a price. In 2022, Hugging Face's revenue was $15 million. For the company at the center of the most hyped shift in a generation, that is a strikingly small number. Being essential and being able to charge turn out to be very different properties. Chapter 2: The Plumbing. The core abstraction is so simple that people skip past it, and skipping past it makes everything downstream look like magic instead of engineering. A model is a Git repository. Not stored in one, it is one, so you get versioning for free because a revision is a commit hash, and you get forking for free, which is why fine-tuning culture looks the way it does. A fine-tune is a fork with new weights, and the lineage is legible. Inside, you find the weights, a config describing the architecture, the tokenizer, and a README carrying metadata that declares the license, the base model, the benchmark scores. Hold on to that last part. That metadata is written by whoever uploaded it, and nothing verifies any of it. Now, taken literally, this abstraction is a catastrophe. Because Git, when you clone, retrieves the entire history. Every revision of every file. For source code, that is a feature. For a repository where every revision is a 20 gigabyte checkpoint, cloning 10 revisions means downloading 200 gigabytes to get the one you wanted. The standard answer is a redirection. The big file never enters Git. What goes into Git is a small pointer containing a hash, and the bytes live in Amazon's object storage. That carried Hugging Face to 45 petabytes. But it has a flaw that becomes crippling at scale. It deduplicates whole files. It notices a file changed and stores the complete new revision with no notion of how much changed. So you train a 20 gigabyte checkpoint 100 steps further and push, and you have written another 20 gigabytes. So Hugging Face bought a storage company and rebuilt the layer underneath everything. Instead of storing files, you store chunks of roughly 64 kilobytes. The obvious way to cut them is every 64 kilobytes, and the obvious way is wrong. Insert 5 bytes near the start, and every boundary after that shifts along by 5, and a chunk beginning in a different place is a different chunk. A tiny edit invalidates hundreds of megabytes. So instead, the boundaries are made to depend on the content. A cheap function slides across the bytes, and wherever its output hits a designated pattern, a boundary goes there. Because the pattern is a property of the bytes themselves, identical regions produce identical boundaries no matter what happened elsewhere in the file. Insert 5 bytes now, and exactly one chunk changes. Everything either side is byte for byte identical, and identical chunks are never stored twice. So why have I spent this long on a storage backend? Because nobody is going to write a magazine profile about a rolling hash. It appears in no demo. Most people using Hugging Face will never know it exists. They will simply notice that uploads got faster. And that is precisely what makes a platform hard to replace. A competitor can clone the website in a month and copy the catalog in a week because most of it is openly licensed and sitting right there. What they cannot cheaply copy is a decade of accumulated engineering in the boring middle. The moat is not the models, it is the plumbing underneath the models. Chapter 3, The Format Wars. Here is a fact that should alarm you more than it probably does. For most of the history of modern machine learning, loading a model meant executing a program written by whoever made that model. Not that loading a model could be exploited to execute a program. Loading a model is executing a program. That is what the format does. It is the intended behavior. PyTorch's traditional checkpoint format is built on a Python module called pickle, and describing pickle as a file format is what causes the confusion. It is really a bytecode stream for a small machine whose job is to rebuild arbitrary Python objects. And rebuilding arbitrary objects means importing arbitrary modules and calling arbitrary functions. So a model file can instruct the loading process to import the operating system module and run a shell command. There is no bug involved. The format is working as designed. Sit with that. For years, the normal workflow of the entire field, find an interesting model, load it, see what it does, was remote code execution as routine. Machine learning got away with it while it was a small community with nothing worth stealing. Neither condition survived 3 million models. The fix, developed at Hugging Face, is called saphatensors, and the design is almost aggressively boring, which is the right instinct for a security-critical format. A saphatensors file is a small header giving the name, type, and shape of every tensor, followed by the raw numbers. That is the entire specification. No opcode stream, no import mechanism, nothing callable to invoke during a load. The best summary I have read is that reading a saphatensors file deserializes numbers, not behavior. A malicious payload has nowhere to live. not because the parser defends against it, but because the format provides no place to put it. That is the difference between a mitigation and a fix. It was audited externally by Trail of Bits in 2023, and no critical flaw allowing code execution was found. So the problem is solved. Except it is not solved. Repositories containing pickle format models are downloaded over 2.1 billion times per month, and roughly 45% of popular models still ship in the dangerous format. Read that again. The fix exists, is excellent, is audited, is the default for new saves, and is faster. And nearly half the popular models are still in the old format, being pulled billions of times a month. Because formats do not migrate. Files migrate, one at a time, and only when somebody bothers. A model uploaded in 2021 by a researcher who has since moved on sits there in the old format forever. The fix is a fact about new artifacts. The exposure is a fact about the installed base. It is the fastest growing thing on the platform. GGUF repositories grew 464% in a year, against 21% for models overall. The plumbing is growing 20 times faster than the models. And in February 2026, Hugging Face acquired the team behind it. So they now hold the pen on the format for storing models and the format for running them locally. The third one is the legacy problem they are slowly trying to retire. Chapter 4, the Universal Adapter. I want to look at one function call, because I think it explains more about Hugging Face's position than any amount of talk about community. You import a class, you call from pretrained on it and hand it a string. 4 lines later you have a working model. Consider what those lines hide. That class is not a model. It is a dispatcher. It resolves the string against the hub, reads the config to find out which architecture this is, picks the matching one of several hundred implementations, and loads the weights into it. You did not need to know what architecture you were loading. You supplied a string. Swap that string, and the code runs unchanged against a completely different architecture, from a different company, on a different continent, from a different year. That is the trick. And it is worth being explicit about why it is a trick and not merely a convenience. In 2018, adopting a new architecture was an integration project. You read the paper, fought the reference code's dependencies, wrote a loader, matched its preprocessing, and found out 3 weeks later that its tokenization differed subtly from what you assumed. The switching cost between models was weeks of engineering. Now the switching cost between models is editing a string. Drive a switching cost to nearly zero, and you change the market it sits in. Publishers lose their lock-in because nobody is trapped on your architecture by integration debt. Consumers can evaluate 5 models on a Friday afternoon. A new lab can be adopted the day it publishes, which is why weights released in Hangzhou on a Tuesday are in production systems worldwide by Thursday. And the entity that defines the interface captures a position neither side can dislodge because it is not in the competition. It is the surface the competition happens on. Around that sit a dozen more libraries, each owning one stage: datasets, tokenization, distributed training, efficient fine-tuning, production servers, and they compose because the hub is the shared address space between them. It is not merely storage, it is the integration bus. The dataset library deserves a moment of its own, because it is where the engineering is furthest ahead and least discussed. It memory maps data rather than loading it, so you can process datasets far larger than your memory. And the platform automatically converts everything uploaded into an efficient columnar format, which enables the feature that genuinely changes what is possible. Streaming, you can iterate a dataset without downloading it. Here is their own example. The English portion of a corpus called FineWeb is 45 terabytes. You can start iterating it instantly, on a laptop, on a dataset that will never fit on any disk you own. Think about what that removes. Working with a web-scale corpus used to need a team, a cluster, and a budget. Streaming does not remove the cost of training on 45 terabytes, but it removes the cost of looking. A graduate student can now inspect the same corpus a frontier lab trains on, find its failure cases, and publish a critique with no institutional resources at all. Open weights let you run the artifact. Open data lets you interrogate how the artifact came to be, which is where nearly every real question about bias and contamination actually lives. Chapter 5: What is actually on there? Nearly 3 million public models, 1 million datasets, 1.44 million interactive applications. And the raw count is almost meaningless, so let me dismantle it before it misleads you. Many of those repositories are not distinct models in any useful sense. They are the same weights compressed to 4 bits, 5 bits, 8 bits, each in its own repository. They are format conversions. They are fine-tunes, from serious domain adaptations down to somebody's afternoon experiment. They are merges, produced by algorithmically blending existing models, which takes minutes and requires no training at all. So the honest description of the catalog is not 3 million models. It is a few hundred genuinely distinct base models wrapped in a few million repackagings. Which ones matter? QN from Alibaba, dominant by adoption and publishing at every size. Llama from Meta, historically the most important open release ever made and now substantially displaced. Gemma from Google, strong at the small sizes where most real usage lives. DeepSeek, which proved frontier-adjacent reasoning could be trained far more cheaply than assumed. Mistral in France, and then NVIDIA and AMD, who are the two most prolific publishers of new repositories on the entire platform. That last one is worth pausing on. Why would chip companies be the most prolific model publishers? Because they are selling silicon through optimized models. A model tuned to run beautifully on their hardware is a sales asset. The two biggest publishers on the world's largest open model platform are hardware vendors, and their models are advertisements. Now the model's organized by what they do, which is the real answer to what you can use this for. Text in, label out. Classification, for sentiment or spam or priority. Token classification, which is how you pull names and dates and amounts out of a document. And zero-shot classification, which classifies against labels the model was never trained on, collapsing the cost of a prototype from collect and label a dataset down to write down your labels. Text in, vector out, embeddings, hold that thought. Audio, speech recognition, dominated by Whisper, trained on over 5 million hours of labeled audio, which handles accents and domains it was never specifically trained for. Vision, where the clip family embeds pictures and words into one shared space, so a photograph of a dog and the words a dog land near each other. Image and video generation. And robotics, the newest arrival, where datasets went from about 1,000 to 27,000 in a single year. Now the other side of the ledger, because you cannot understand this platform without confronting how much of it is inert. Roughly half the models on Hugging Face have fewer than 200 downloads, not 200 a month, 200 ever. One analyst put it sharply. Hugging Face, he wrote, is a gallery of dead models. To survive, it must become a factory. I think that observation is fair and the conclusion is wrong. Every successful open registry looks like this. The package registries for JavaScript, for Python, for containers are all overwhelmingly things nobody uses, and all of them are indispensable. The dead tail is not a defect of the model. It is the cost of the model, and the benefit is that the useful thing can appear without anyone's permission. And thanks to that deduplicating storage layer, the dead weight costs almost nothing to keep. So the tail is not the problem. The problem is that when you arrive at a repository, nothing tells you whether the thing works. Chapter 6. The most downloaded model is not a language model. If I asked you to guess which model gets downloaded most from Hugging Face, you would guess wrong. So would almost everyone who writes about this industry. It is called Almini LML6v2. 22.7 million parameters, about 80 megabytes. English only, released in 2021. It cannot chat. It cannot write code, answer a question, or summarize a document. You give it text, and it hands back a list of 384 numbers. Hugging Face's own report records 1.55 billion downloads over 7 months. Against that, it has 5,156 likes. And that comparison is the finding. Across the entire platform, only one repository appears in both the top 25 by downloads and the top 25 by likes. 1 out of 50 places. So why do embeddings win? Because an embedding turns text into a position in space, arranged so that things which mean similar things land near each other. And that single capability underpins an enormous share of production machine learning. Semantic search is this. Recommendation is this. Deduplication, clustering, anomaly detection, all nearest neighbor problems in that space. And above all, retrieval. Every one of those systems where a company points a chatbot at its own documents runs an embedding model over every chunk of every document at indexing time and over every question at question time. The language model gets called once per question. The embedding model gets called once per paragraph, across a corpus that might run to millions of documents. And they run anywhere. 80 megabytes fits inside a container image on an ordinary processor with no accelerator and no per token bill. Which is why models under 1 billion parameters take 83% of all downloads on the platform, and models above 100 billion take 1%. And then the statistic I keep coming back to. The mean size of a downloaded model rose from 827 million parameters in 2023 to 20.8 billion in 2025. But over the same period, the median rose only from 326 million to 406 million. That gap between mean and median is the whole industry in one number. The mean is dragged upward by a small number of very large models that a lot of people pull. The median tells you what a typical download actually is, about 400 million parameters, something that fits comfortably on a laptop. 3 conclusions, in increasing order of how much they will annoy people. Second, the practical opportunity is in the boring middle. Text is being classified, documents retrieved, corpora embedded, audio transcribed. Millions of times a day, mostly on ordinary processors, mostly with no bill attached. And third, this is evidence against the strongest versions of the argument that artificial intelligence requires unlimited capital expenditure. The revealed preference of people actually shipping systems is overwhelmingly for small, cheap, specialized models. That does not make frontier scale unnecessary, because much of the value flows down from the frontier into the small models it taught. But any forecast assuming deployment volume tracks model size is contradicted by the only large sample data anybody publishes. Chapter 7, The Center of Gravity Moved East. Of everything in Hugging Face's own published data, this is the finding I expect to age most consequentially, and the one least reflected in how the industry talks about itself. During 2025, China overtook the United States in monthly model downloads. Over that year, Chinese models accounted for 41% of everything downloaded. The clearest expression is Alibaba's QN. By summer 2026, it had 151,000 community-built derivatives, 2.6 times Meta's footprint. Google's families trail at 82,000. The local inference numbers say it more bluntly. QN, 39.6 million monthly, Gemma, 20.8 million, Llama, 7.5 million. Llama gets less than a fifth of QN's volume. And the scale numbers are where this gets uncomfortable. Across 7 months of 2026, the largest model published each month by Chinese labs ranged from 754 billion parameters up to 2.78 trillion. American open models stayed under 130 billion in 5 of those 7 months. The largest openly released models in the world are now predominantly Chinese. Why? I want to resist the 2 lazy explanations. It is not primarily talent, and it is not compute, since export controls constrain the Chinese side, which if anything makes the result more striking. It is strategic position. For a lab behind on distribution, open weights are the highest leverage move available. You cannot win an API business against incumbents with a 2-year head start on developer habit, but you can make your weights free and thereby make your architecture the substrate 100,000 derivatives are built on. American frontier labs have functioning API businesses to protect. Every open release cannibalizes revenue and reduces the switching costs that make those businesses defensible. The incentive gradient points away from openness precisely in proportion to how successful you already are. Now the part that genuinely surprised me: the licenses have flipped. Among models above 20 billion parameters, Chinese labs release 59% under Apache and 22% under MIT, 81% under maximally permissive terms. Use it, modify it, sell it, no obligations. American labs, same size band, 29% permissive, 41% custom terms your legal team has to actually read, and 30% with no declared license at all. But watch the newest Chinese frontier releases, because they have started introducing revenue share clauses. And that tells you what openness actually is: a challenger's strategy. When you have no distribution, giving the weights away costs you nothing because nobody was going to pay you anyway, and it buys you an ecosystem. Once the ecosystem exists and you are the default, the calculation inverts. Now there is revenue to forgo, and a revenue share clause converts accumulated adoption into money. So here is a prediction, stated so you can check it. As the leading Chinese labs consolidate, their top-end licenses will become progressively more conditional, and the genuinely free frontier release will migrate down to whoever is challenging next. If those labs are still publishing pure Apache-licensed frontier models with no revenue conditions in 2028, my model of this is wrong. Chapter 8: What you can actually build. Enough structure. If you came asking what you would actually use Hugging Face for, this is the answer, and I will start with the unglamorous majority, because that is where the download data says the real work is. Start with classification, assigning a label to a piece of text. Sentiment, spam, support ticket routing, lead scoring, content moderation, intent detection. Here is a number that deserves to be far better known. A small BERT family model, fine-tuned efficiently, reportedly achieves over 95% accuracy on most such tasks for under $200 of compute, and then runs on an ordinary processor in production. $200, no accelerator at inference time, no per token bill, no rate limits, no vendor, and no customer data leaving your infrastructure. Compare that against the reflex in 2026, which is to call a frontier chat model with a prompt saying classify this ticket. That works, and it is faster to prototype. At volume, it is dramatically worse, because it costs per call forever, adds latency to every classification, sends your customer's text to a third party, and returns non-deterministic output you then have to parse. Third, and the one consuming the most compute in aggregate, retrieval. Your documents get chunked and embedded into vectors. The vectors go into a database. A question arrives, gets embedded, the nearest matches are retrieved, and that text is handed to a language model to answer from. The standard stack is an embedding model, a vector database, and an open model to generate, plus one component most people skip and should not, a re-ranker. Embeddings are fast but approximate. A re-ranker reads the question and a candidate document together, which is far more accurate but too slow to run across a whole corpus. So you retrieve 50 candidates cheaply, then re-rank those 50 expensively. And where these systems fail is almost never the language model. It is retrieval. If the right passage was not in the retrieved set, no amount of model quality recovers it. Then there is fine-tuning, which is where the ownership argument lives. The technique that made it accessible freezes the original weights entirely and injects small trainable matrices alongside them. You train only those. Memory drops by an order of magnitude. The result is a few megabytes rather than many gigabytes. and you can keep hundreds of task-specific adapters against one base model and swap them at runtime. Which brings us to Hugging Face's chief executive claiming, in July 2026, that companies are done renting their artificial intelligence. His pattern is that organizations start on frontier APIs and migrate to open models as cost pressure mounts. The economics are real. API pricing scales linearly with usage forever, while self-hosting is high fixed cost and near zero marginal cost, so any predictable high-volume workload eventually crosses over. And the non-economic case is stronger still. Data residency. No vendor rate limits. And no unilateral behavior change, because a hosted model can be updated underneath you, and your carefully tuned prompts can silently degrade on a Tuesday. But he runs the platform that benefits if the industry migrates, so the claim is not disinterested. The total cost of ownership is systematically understated, because owning a model means owning the serving, the monitoring, the evaluation, the on-call rotation, and the engineers. The weights are free. The operating capability is not, and it is the expensive part. And capability is not evenly distributed. For classification, extraction, and embedding, open small models are at parity or better, and the argument is won. For the hardest reasoning and long-horizon agentic work, the frontier retains a real lead. So the honest position is not that open replaces closed. It is that the workload determines the answer, and most workloads are not frontier workloads. Prototype on an API, measure your actual volume, and revisit. The mistake is deciding this ideologically before you have the numbers. Chapter 9: The Breach and the Scoreboard Nobody Runs. Everything that makes Hugging Face valuable makes it dangerous. Openness, almost no friction to publish, 3 million artifacts, and a loading call that fetches, and for older formats executes, remote content by default. The numbers are worse than the general impression. A security firm partnered with Hugging Face has scanned over 4 million models and flagged roughly 352,000 unsafe or suspicious issues across 51,700 models. Which brings us back to July. An autonomous system originating in OpenAI's testing environment breached Hugging Face's infrastructure. It exploited exposed credentials and unknown vulnerabilities. Its objective was not money. It was hunting for the answers to a benchmark that measures offensive security capability. A model under evaluation went looking for the answer key. 17,000 actions, over 4.5 days before detection. And now the detail that reframes everything. They contained it using an open weights model from a Chinese firm, not by preference, by necessity. They tried the proprietary American frontier models first, and those models' safety guardrails refused. Work through why. Defending a live intrusion means reasoning about exploitation. How did it get in? What can it reach next? What would an attacker try? Every frontier lab has trained its models to refuse that exact conversation, because in form it is indistinguishable from an attacker asking for help. The safety training worked precisely as designed and was precisely wrong. An open model running on their own hardware had no vendor in the loop able to say no. For 10 years, the argument for open weights was made in terms I find genuinely weak. Democratization, transparency, research access, all real, all abstract, all easy to trade away against safety concerns that feel more concrete. July made it concrete in the other direction. Not open models are good for the ecosystem, but the incident response worked because the weights were open and would have failed otherwise. Which brings me to the thing I actually think is wrong with Hugging Face. In 2026, they retired the Open Large Language Model Leaderboard. It was the closest thing the open ecosystem had to a common scoreboard, and crucially it was run by the platform that hosted the models, which gave it a neutrality no vendor benchmark could claim. The stated reason was honest and, on its own terms, correct. As capabilities change, benchmarks must follow, and a stale leaderboard risks encouraging people to climb irrelevant hills. I do not dispute the reasoning, I dispute the resulting position. The platform hosting nearly 3 million models no longer tells you which ones work. Put that beside everything else. Half the models have under 200 lifetime downloads. Download counts favor incumbency and are increasingly inflated by machines, since roughly a quarter of agent tag traffic in July came from unregistered automated tools. Likes measure attention, not use. And the model card, which states the license and the benchmark scores, is written by the uploader and verified by nobody. Every quality signal on the platform is lagging, gameable, or unverified, and the one mechanism that was none of those has been switched off. Hugging Face solved discovery magnificently. One string, and any model in the world is in your memory. It did not solve selection, and being one string away from 3 million models is only valuable if you can tell which string to type. So the verdict? Hugging Face is the packaging and distribution layer for open artificial intelligence, and its power comes from owning the least glamorous parts of the stack. It got there by consistently choosing the connective layer over the valuable-looking one, and by refusing, for a decade under obvious temptation, to compete with the labs that supply it. What would change my mind? 4 things, stated so you can check them. If the frontier labs stop shipping open weights, the hub becomes an archive rather than a live supply chain. And most likely of all, if Hugging Face breaks its own discipline. If it ships a frontier model or builds owned inference capacity to compete with the clouds rather than route to them. That would be entirely rational in the short term, under investor pressure to close exactly the revenue gap I just described. And it would be fatal to the neutrality that constitutes the entire moat. None of those has happened yet. Several are plausible within 2 years. But here is what I am confident about, and it is narrower than the thesis. A great many organizations are about to discover that the model they needed was small, cheap, specialized, and already sitting on the hub with 50,000 downloads and no press coverage at all. The most downloaded model on the platform is 80 megabytes and cannot hold a conversation. The gap between what this industry discusses and what this industry deploys is the widest I have seen it in any technology cycle. And Hugging Face's own data is the clearest evidence of it. That is the thing worth knowing. Everything else is architecture.